Hello, good afternoon, everyone. Good afternoon, everyone. I welcome all of you to the most comprehensive exam preparation app, that is BYJU'S app on YouTube channel. All of you, please join fast. So from today onwards, we'll be completing our soil mechanics, and today is the topic for three-phase of soil. I welcome everyone. I hope I am audible to all of you. Let us move towards our course. This is my introduction, and this is the plan. On 9th of November, that is, I'm going to conduct consultation, then shear strength on 11th of November. It will continue, so please be there so that we can learn from soil mechanics. This is my Telegram channel. You can join the Telegram channel, which is Civil by Md Ansari Sir. Please share it and like it. Let's start our session. This is the star faculty of our BYJU'S Prep for Civil. These are the courses going on, that is for Vision 2022 and Rank Up, and for Vision 2023 they all are for GATE Aspirants. Now, in the three-phase of soil system, what we are going to see today: the different type of density of soil, unit weight of soil, then the definitions of void ratio, degree of saturation, specific weight, then the important formula which has to be utilized, and the numericals on it. Let us go through one by one. As you know, the soil constitutes the solid particle and a void. So if you consider any of the mass of the soil, it constitutes the solid particles. This is the representation just in front of you, which will be having the solid particles and the void. For easy calculation and understanding, what we generally used to do, we segregate this solid particle and the void in a two different part, and we are representing like this. This is the representation only for the easy understanding and calculation purpose. And this one we are calling it as a two-phase of the soil, where it has only the solid particle and the void. Now that void may be contained with the water and as well as air. That void will be having air as well as water. Suppose some of the portion of void is filled with the water. How it does look like? Some of the portion, if it is filled with water. Now if you want to represent it in your system, then some of the portion here, if you'll see in right side, just have filled with the water, that's all. This we are calling it as now three-phase of system. So the mixture of soil, any mass of soil which is a mixture of constituents like solid particle and the void may contain either air or water. So mixture of all these three, we are calling it as three-phase of system, where you have a solid particle, then you have a water, and you have a air. Now suppose you have a soil and the solid particle. This is your dry soil. If you don't have any water inside it, we are calling it as a dry soil. It may be filled with completely with all the voids may completely get filled with the water. If all the voids are completely filled with the water, then we are calling it as saturated soil. How we will represent it? This is the representation for our three-phase of system. Now it will become only two-phase, because the void is completely filled with water. No air is present here. Then we are calling it as a fully saturated soil. All the voids are now filled with the water itself, and this is the representation. So the void, I'm going to say that this void, the volume of the void either will be filled with air and water, or completely only with the air, or maybe completely filled with the water, right? Now, as you know, density is nothing but mass by volume, and the unit weight we are calling it as weight by volume, isn't it? Weight by volume. Now we will see different unit weight or density of the soil. Consider soil. This is the tank which is filled with the water. Inside that water, if you will immerse the saturated soil inside it, what will happen? If you have a saturated soil inside the water, of course, the saturated unit weight, as I told you, the unit weight is nothing but weight by volume. So whatever the weight now, whatever the weight for this soil will be here during the submerged condition, that weight under submerged condition divided by volume. Whatever the volume of the soil you have will give you the submerged unit weight. Then how you will understand what is the submerged unit weight? If you are submerging, if you are immersing your soil inside the water, what will happen? It has a weight which is acting downward side, and the buoyancy force will be acting upward side. And the weight, that is submerged weight, will become now, the weight of submerged soil will become the total weight minus the buoyancy force. Right? The weight of submerged soil, I can write it down. If the volume total is V and submerged unit weight, if I am considering as a gamma dash, then V into gamma dash will give you the total weight of your submerged soil, which is nothing but the total weight. Total weight when it is outside, which is nothing but the total volume into the gamma saturated, the saturated soil, minus the buoyancy force. Whatever the water has been displaced, the weight of that water, whatever the water has been displaced by this volume, the weight of that water, isn't it? So the volume of this soil multiplied by unit weight of water will give you the total buoyancy force, which is going to act on the upward side. And hence you will get the gamma submerged. So gamma submerged is gamma saturated minus gamma W. Now soil, if it is completely dry, means the all voids are completely only filled with air, no water is present in this particular void, then what is the unit weight? The unit weight, I can say that weight of the dry soil by volume. And its particular process, in this particular process you can identify there is no change in the volume. I'm just considering the same volume, constant volume throughout I'm keeping it. So if I'm going to keep the throughout same volume, you can understand what will be the unit weight for different type of situation, right? So dry unit, just you can consider what same for the same volume. If all the voids are just filled with the air, so weight of the dry soil by volume will give you the dry unit weight of the soil. Then if the soil is slightly filled with water, some of the portion of the void is slightly filled with water, this type of soil we are calling it as bulk soil. So just take the weight of the soil. So at that time, if you take the weight of the soil divided by once again the same volume, will give you the unit weight that we are calling it as bulk unit weight. Then if the soil is completely filled with the water, the soil voids of the soil is completely filled with the water, at that time if you consider the weight of the soil mass, then the unit weight calculated at that time will call it as saturated, gamma saturated, the weight of saturated soil by total volume. Then you can consider the whole volume if I'll fill with the only solids, there are no voids at all. The complete volume, if you'll fill with the solid, at that time if you'll calculate the unit weight, will call it as unit weight of solid only. Now it will be easy for you to correlate between these all. The gamma of solid, gamma of saturated, gamma of bulk, gamma of dry, and gamma submerged. Which one is greater, which one is smaller? And one more thing you can identify from here, that bulk unit weight, the bulk unit weight, the maximum you can get when it is saturated, fully saturated. So the bulk unit weight will be always between the maximum saturated unit weight and the dry, isn't it? Between these two you can get anything. And the lowest one you can say that it is your nothing but gamma saturated, gamma submerged. The lowest unit weight you can say that it is a gamma submerged, which is gamma saturated minus gamma W. Now if I'll ask to solve you this question, this problem, for a soil sample arrange the following increasing order. From the previous slide you can just identify. As I told you, this gamma submerged is the lowest one. If you are going to arrange in the increasing order, first one will be your 2. This is the lowest one. Then second one you can see from this diagram. Second one will be obviously the dry one. Third one will be obviously the bulk. Fourth one will be your saturated. And fifth one will be your gamma solid. Are you able to understand that? Yes, good evening. Yes, this is the first class of soil. On 9th I will be conducting consultation. Then after that I will be taking shear strength, then shallow foundation and pile foundation. So now it is easy for you to understand. This the submerged will be the lowest one. After that you have a dry, that is third one. Then after that you have a bulk, first one. Then after bulk you have a saturated, which is fourth one. Then after that you have a unit weight of solid. This is the largest one. So the option of obviously will be C. Now let us move to another one. Few definitions we'll see. Please do not forget to like the session and also share with your friends. As I told you, you have a three constituents in your soil mass, which is a solid, water and air. And this is the representation of all this mixture. Of course, this is the constituents we are representing for our easiness, isn't it? In this three-phase system. The volume of solid, volume of void and volume of soil, total volume of soil. Now, few of the definitions you have to understand. The void ratio we are defining as the volume of void by volume of solid. The porosity we are defining as the volume of void by total volume of the soil. Then percentage air void always, along with the void ratio and porosity, those who are preparing, always remember the percentage air void with porosity and void ratio. There is a reason behind that, so that you will not get confused, because the percentage air void is nothing but volume of air with respect to total volume of the soil. So remember these three together. Then next one, the degree of saturation. It is nothing but what is the percentage of water present inside the void. If I'll say that the void is 100%, if it is 100% free from water, total air will be 100%, that's all. Then I can say that 20% of the void is filled with water, 30% of the void is filled with water, 50% of the void is filled with water, or maybe the 100% of the void is getting filled with water. That percentage which I am recognizing, which I am saying it to you, that is nothing but the degree of saturation, which will define as volume of water with respect to volume of void. In terms of course, we can say that either percentage or from 0 to 1. Then the air content, always try to remember along with the degree of saturation, because if I'm saying that 30% of the void is filled with water, of course, then you can say that, of course, then 70% of the void will be filled with air. If I'll say that 60% of the void is filled with water, then 40% of the void will be filled with air. So that air content is defining as the volume of the air with respect to total void. Volume of the air with respect to volume of the total void. Then one more thing, do not get confused with the degree of saturation and the water content. Water content is with respect to the weight. It is nothing but the weight of the water present in the soil mass with respect to the dry weight of the soil. The water content is nothing but weight of water with respect to dry weight of soil. These are few important definitions which you have to remember. If you see the range of the void ratio and porosity and degree of saturation and water content, that is also quite interesting. Void ratio. What is that? Volume of void by volume of solid. You can tell me what will be the range. If there is no void at all, although it is a hypothetical condition, so it may reach to 0. Now continuously, now you imagine this is the volume of void. If I want to increase the volume of void may go beyond the volume of solid, isn't it? Now this is the volume of solid. Can you see that? And this is volume of void. If the volume of void is increasing enormously, you can say that of course it can go beyond 1, isn't it? So volume of void, if I'm increasing, volume of solid may get reduced continuously. A very small volume of solid is present here. So I can say that the void ratio has a range of which is greater than 0. It may be greater than 0, greater than 1, greater than 2. Then let us see what will be the range of porosity. The porosity, you can see that volume of void by volume of soil. The volume of soil is nothing but the total volume I'm talking about. Whatever the way you are increasing the volume of void, it cannot go beyond volume of soil, of course. So porosity will be of course greater than 0, but it cannot go beyond 1. To go beyond 1, how you can imagine? The total soil volume is in the denominator. So volume of void total, it may become, although it is hypothetical once again, the volume of void maximum will become total volume of soil itself. It cannot go beyond that. So the porosity will be between 0 to 1. A degree of saturation is also from 0 to 1. Either the void is totally free from water, so degree of saturation is 0, no water present in the void, or the void is completely filled with water, then the degree of saturation may become 1. Now let us talk about the water content. The weight of water by weight of dry soil. For that also I'll let you know. You contain what, take a container. Take a container and a slurry of a soil. Slurry. Then let us dry it. Now just you took the slurry of the soil, take the weight of that, then dry it. After that, if you'll subtract, you'll get the weight of water. Too much weight of water divided by weight of dry soil. Are you able to understand that? Now, if you have a slurry of soil, after drying it, of course, you'll get very small amount of the soil. So you can say that, of course, water content also may go beyond 1 to anything. Water content will also can go beyond 1 and 2. It will be greater than 0. Are you able to understand that? If you have any doubt, please let me know. These are very helpful. That may be also 0 also sometimes, the water content. Now, let us understand about apparent and true specific gravity. First of all, I'll ask you, what is the definition of your specific gravity? For a standard temperature and pressure, you can say that the specific gravity is nothing but weight of soil by weight of water for the same volume. Weight of soil by weight of water for the same volume at standard temperature, isn't it? If I'll say that you have a container, understand it, it will be very helpful for you. Filled with the soil, take the weight. That's all. For the same container, filled with the water, take the weight. So it is going to represent whether the soil is lighter than your water or heavier than your water. That's all. That is the meaning of your specific gravity, isn't it? But generally, we are not representing in terms of weight. We are representing in terms of unit weight. Why? Because see, as I told you, the volume must be same. So it's better to go for the unit weight of the soil and unit weight of the water. So it is nothing but unit weight of soil divided by unit weight of water. Isn't it? Because the weight of soil, I can write it down, weight of soil divided by volume for the same volume, and weight of water divided by same volume. So volume get. Now you can understand. If you are no problem at all. If you are taking the unit weight, then I should not say for the same volume or what, right? But for the understanding purpose, you should remember, for the same volume, take the weight of soil and take the weight of water. That is the comparison. The ratio between those two are nothing but your specific gravity. Now, if I have a soil, there is no water inside it. This is the representation of the soil, two-phase system. This is your solid and this is your air. The complete void is filled with air itself only. If I'll ask you, what is the specific gravity? The specific gravity will become now dry specific gravity. Why? Gamma of dry soil by gamma of water. That is unit weight of this soil. Unit weight of this soil. Which is nothing but weight of, already you know, gamma of dry soil means what? Weight of dry soil by the volume of soil, right? Divided by gamma of water. If I'll ask you, sometimes maybe, if I'll say that if few portion of the void is filled with water, what is the now specific weight? Now you will go and you will take the weight of this soil. If few portion of the void is filled with water, now you will get some another weight. So that weight, if you are taking some bulk weight divided by volume, volume is not changing at all. So that unit weight, you will call it as bulk unit weight. So specific gravity will become, this is the representation. Now specific gravity, I'll say that it is nothing but unit weight of bulk soil divided by unit weight of water. Unit weight of bulk soil by unit weight of water. That one we are calling it as an apparent specific gravity. Sometimes we are representing with M also in a suffix. Now, if I'll ask, maybe if the complete void is filled with the water, that is what I'm calling it as completely saturated soil. Then this is the representation of our, now this will become two-phase system because it has only solid and water. What is the specific gravity? That specific gravity will call it as gamma of bulk now is nothing but your saturated. Gamma of bulk is now saturated. Gamma saturated by gamma of water, that unit weight of water. You can understand specific gravity at different situation is changing at all. Gamma, the dry soil, gamma of your saturated soil, gamma of bulk. There is a huge variation. That all we are representing with apparent specific gravity. So it is a variable quantity. Apparent specific gravity for a particular situation will be any. So this value can vary from certain limit. Whether it's a dry or saturated or in between, what is the percentage of void filled with the water, depending on that, you will get some different specific gravity. So that apparent specific gravity we are defining as gamma of bulk by gamma of water. The next one is the true specific gravity, which is never going to get changed for a particular type of soil. For a particular type of soil, whether it is completely filled with water or it is completely filled with soil, air, whatever the situation it is having, the specific gravity is not going to get changed because we are considering the whole volume is filled with solid only. If the complete volume is getting filled with the solid, then you calculate what is the weight of the solid divided by volume. That will give you the unit weight of the solid. Hence, the true specific gravity is nothing but unit weight of solid by unit weight of water, which is the maximum one. This is the maximum one. And this one we are calling it as a true specific gravity. Every time whenever in the formula we are writing down, we are never specifying any apparent specific gravity because it is changing, keep on changing. It's a variable one. So true specific gravity is represented everywhere. In every formula. Although now, we are not writing GS every time, simply we are writing down G, but it is representing our true specific gravity. Now let us see few of the important formula which is very helpful for you and you should always go through it. Now if the volume of solid, if I'll consider as 1, the total void will become now E. The total void will become E, isn't it? Then the total volume of the soil will become 1 plus E. And first formula is your porosity. Now porosity, the definition of porosity is what? Volume of your void by total volume. So volume of void is now E and the total volume 1 plus E. The second formula you should remember, which is related to ES equals to WG. E is your void ratio, S is your degree of saturation, W is your water content and G is your specific gravity. In all the formulas, specific gravity is nothing but your true specific gravity. Those who are preparing, this is my way of understanding. See, you remember few of the formulas are important, that's all. Based on that, you try to solve as much as problem and it will be really helpful. Third very important formula is your gamma D, which is gamma bulk by 1 plus W. W is your, once again, water content. Fourth one is your very important gamma, G plus ES by 1 plus E into gamma W. Here also you can see one thing. If the degree of saturation will become 0, means you have a dry soil. The S will become 0, then this gamma I can write it down, gamma D will simply become G by 1 plus E into gamma W. And if the degree of saturation will become 100% saturated soil, S will become 1. Hence, this gamma will be known as gamma saturated, which is now G plus E divided by 1 plus E into gamma W. And the fifth one, very important formula, which is for relative density, which is E max minus E by E max minus E. This is utilized for the kind of gravel soil or maybe sand. Relative density, whether the sand is in a loose condition or in a dense condition. It varies from, maybe if it is from 0 to 15, you can say that it is a loose soil. ID value, if it is from between 85 to 100, we can say that it is a very dense soil. These are the very important formula, just go through. I'm just saying it the way I am explaining it to you. If you will just go through this formula and the few definitions which I have given it to you, just you remember these things, understand these things and practice, most of the questions you can solve from the first chapter. Now let us solve few of the problems here. The true and apparent specific gravity of a fully saturated soil is 2.7 and 2.0. What will be the void ratio? Can you solve this one? As I already told you about the true specific gravity and apparent specific gravity. The apparent specific gravity is nothing but gamma of bulk by gamma of water. Fortunately, if you read out the question carefully, the true and apparent specific gravity of a fully saturated soil. We know that the soil for which he is defining the apparent specific gravity, it is actually fully saturated. Hence, the gamma bulk, as I told you, gamma bulk has a variation from gamma saturated to gamma dry, isn't it? Now it is saturated. Fortunately, the information has been given. So gamma of apparent, so no, sorry, specific gravity for apparent specific gravity is given as 2. It will be nothing but 2, and gamma saturated will become simply 2 into gamma W, and gamma W if I'll consider as 1, that is 1 gram per cc, it will become 2 gram per cc. The gamma saturated is now 2 gram per cc. He's asking about what is the void ratio. As I told you, it is a fully saturated soil. Now remember the formula as I gave you now. From those formula only I'll be utilizing. I'll be using those formulas, that's all. G plus ES divided by 1 plus E into gamma W. Now if it is a fully saturated, I can use gamma of saturated, S will become 1, hence G plus E divided by 1 plus E into gamma W. Use it. If I'll use this one, gamma saturated now is nothing but 2 gram per cc, so it will become now 2 will be equals to G is also given, which is the true specific gravity 2.7 plus E divided by 1 plus E into gamma W is 1 gram per cc, as I am using gram per cc as my unit. So gamma W is 1 gram per cc. 2 I have utilized as gram per cc. From here, if you will calculate the E value, it will become 2 plus 2E will be equals to 2.7 plus E, and E will become 0.7. That's all, isn't it? Solve the another one. If the moisture content of a fully saturated soil is 100%, then the void ratio will be. If the moisture content of the fully saturated soil is 100%, then what will be the void ratio? GS represents the true specific gravity and GM is representing your apparent specific gravity. Right? Now if the moisture content of a fully saturated soil, so if you write down ES equal to WG, you can find out there are two information provided here. If the moisture content means nothing but the water content. If the water content of soil, not soil, a fully saturated soil means, see, the two information he is providing together. A moisture content means the water content is 100%. At the same time, he is saying that it is a fully saturated soil. So S is also 1. W is 1, S is 1, simply E will become G. That G is what? The true specific gravity. I told you, in formula wherever we are utilizing, it is nothing but your true specific gravity. Hence, the void ratio simply will become true specific gravity. That's all. Next one. This is the volume of sand, weighs 1010 gram. Its dry weight is 918 gram. And the specific gravity is given as 2.67. What will be the void ratio? What will be the void ratio? So here, just can you calculate it? Can you just calculate this one? Once again. Yes. Now, the volume of sand weighs 1010 gram. Its dry weight is given as 918 gram. He is asking what will be the void ratio. If the dry weight of the soil is given, you can simply calculate the dry density, which will be nothing but dry weight of the soil by volume of the soil, which is nothing but 1.56 gram per centimeter cube. Can you just calculate it? Then he's asking about the void ratio. How will calculate? As I told you, once again I am going to use the same formula, that is G plus ES divided by 1 plus E into gamma W. If it is a dry soil, the degree of saturation will become 0 and this gamma will become gamma D, which is G plus ES. Once again G is given, which is 2.67, and plus nothing divided by 1 plus E into gamma W. It is given in gram per cc. Gamma D already you got 1.56 and gamma W keep it as 1. In gram per cc gamma W, the water unit weight of water is 1 gram per cc, 1 plus E. That's all. From here just you calculate the value of void ratio, that will become almost around 0.7, isn't it? Yes, Harita, absolutely correct. Now can you solve this one? You can consider this as a MSQ problem for your GATE examination. This is the one kind of problem, one kind of numerical they're asking, where maybe 2 options are correct, maybe 3 options are correct. A moist sample from a borrow pit has a natural moisture content of 15% and a bulk unit weight given. If the G value is given, which of the following is or are true? Which of them are correct here? Which of them are correct here? Gamma bulk is given here. Gamma bulk. The bulk unit weight is given. Gamma of bulk. Gamma of bulk is 1.9 and the water content also is given, that is nothing but your moisture content. Can you see that? Which is 15%. So W is also given 0.15. So you can simply calculate gamma D. Gamma bulk by 1 plus W. Keep the value here, 1.9 divided by 1 plus 0.15, and if you calculate, you'll get around 1.65 gram per cc. Once you have calculated gamma D, of course you can calculate the void ratio by using the same formula which we have utilized earlier. That gamma D will become now, gamma D already you know that is G by 1 plus E into gamma W. By keeping that degree of saturation as 0, gamma D value I just calculated can you just calculate it? I think 1.65 gram per cc. So 1.65 equals to G. G they have provided, that is 2.7 divided by 1 plus E into gamma W, keep it as 1 gram per cc. Hence from here if you calculate the void ratio, you will get around 0.64. The void ratio you will get around 0.64. So void ratio is correct. The dry density is incorrect. Now calculate the degree of saturation, which is nothing but ES equals to WG. The water content is 15% and void ratio also you have. So 0.15 into 2.7 divided by void ratio is your 0.64. If you will calculate in terms of percentage, it will become 0.63. In terms of percentage, it will become 63%. 63.33%. Whereas it has given as 6.3%, which is wrong once again. The last one is your saturated unit weight. How you can calculate the saturated unit weight? So gamma saturated, just you see at the top left corner, gamma saturated if you want to calculate G plus ES, S will become 1, G by 1 plus E. You have a gamma W. G value already you have, that is 2.7 plus void ratio you have calculated 0.64 divided by 1 plus 0.64, the whole multiplied by 1, If you calculate gamma saturated from here, you will get around 2.036 gram per cc. Gram per cc, which is almost same. So option D is also correct, isn't it? Yes, Haridha. Now solve this problem. A fill having a volume of 150 cubic meter is to be constructed at the void ratio of 0.8. The borrow pit soil has a void ratio of 1.4. The volume of soil required to be excavated from the borrow pit will be. How to solve this problem? Remember, suppose I'll say that the volume of solid is Vs. You know that volume of void. Your void ratio is what? Volume of void by volume of solid. Hence the volume of void I can write down, that is nothing but E into Vs. Correct, no? E into Vs. And from here I can write down the total volume is nothing but the total volume of the soil is nothing but summation of these two. And summation of these two, if you do, from here you can take the common Vs. So it will become 1 plus E. Are you able to understand that? So volume, the total volume equals to now Vs and 1 plus E. From here, this volume of solid I can write it down. Volume of solid I can write it down, that is total volume by 1 plus E. Now you have a borrow pit and you have some excavation portion. From the borrow pit, actually you are excavating the soil and you are going to fill it somewhere. You want to fill a 150 cubic meter which has a void ratio 0.8. The soil which you are excavating from some borrow pit has a void ratio 1.4. He is asking what volume you should excavate. How much volume you should excavate. See, when you are going to excavate, you can understand one thing. It has a larger void ratio. If the larger void ratio, you will take the soil to your fill, then you are going to reduce the void ratio to 0.8. If you are reducing the void ratio, what does it mean? You are actually reducing the void. Ultimately, if you are reducing the E value, no one is reducing the solid volume. You are reducing the void volume and consequently the total volume is going to get reduced. Isn't it? So if you want to fill 150 cubic meter of the volume, you need to excavate more volume so that you can fill it, then you can compact it to the 0.8 void ratio. And this formula will be very much helpful. V1 by 1 plus E1 will be equal to V2 by 1 plus E2. Volume of solid will be same. Whatever the volume of solid is required here to fill, that amount of the volume of solid at least you need to take it out from that particular borrow pit. So equate the volume of solid for both of them. As to the fill, I know 150 cubic meter is the volume which you require and the void ratio is 0.8. The volume I need to calculate for my borrow pit where the void ratio is given as 1.4. If you calculate the V2 from here, you will get around 200 cubic meter. 200 meter cube. Yes. Now see another problem. If the porosity and degree of saturation of sample are 0.7 and 40% in 100 meter cube soil of volume of soil, what will be the volume of air? What will be the volume of air? Porosity they have given as 0.7 and the degree of saturation they have given as 40%, or you can say that 0.4. in 100 meter cube of volume of soil. So total volume of the soil is given as 100 meter cube. What is the definition of porosity? Porosity is volume of void by volume of soil. Now volume of soil is already known to you, which is 100 meter cube. 100 meter cube. Hence Hence, volume of void will become 100 into 0.7, that is 70 meter cube. Right? Centimeter cube is the. Now, what is the definition of degree of saturation? Which is volume of water by volume of void, which is given as 0.4. Volume of void, if you have calculated volume of void, now volume of water will become 70 into 0.4, and you will get around such what has 28 meter cube. This is the volume of water. Once you will be able to calculate volume of water, you know the total volume of void is nothing but summation of volume of water and volume of air, isn't it? Volume of void already you have, that is 70. So volume of air will become 70 minus 28. That's all. 42. Just go through this formula and calculate few of the numericals. Practice more and more numerical. It will be really helpful for you. Can you solve this one? The porosity of a sand sample is 0.375 and its density index is 0.6. If the dry density in the loosest state is 14.21 kilonewton per meter cube, then the void ratio in the densest state will be. He's asking what is the void ratio in the densest state. The density index has been given. I already gave you the formula for density index, which is nothing but Emax minus E divided by Emax minus E minimum. You already know that if the density, dry density, the loosest state, maximum void ratio will be having. Loosest state means void is more. Densest state, void is less, isn't it? Dense means voids are less. So in the loosest state, if I want to calculate, I will get the maximum void ratio. The porosity is given as 0.375. First of all, the natural void ratio, if you will calculate from here, you will get void ratio will become n by 1 minus n. That is nothing but, if you will calculate how much you're getting. 0.6. Yes. This is your void ratio natural. Now you calculate during the dry density in the loosest condition. So I will just use gamma d equals to G by 1 plus E into gamma W. Now understand it. If I'm going to use the dry density in the loosest condition, obviously I'll be getting E max. So I'll just, first of all, I'll just make sure this will become E, that is 1 plus E. E will become how much? G gamma W by gamma D minus 1. Now if I am going to put the value of gamma D as the loosest one, I will get the E maximum, isn't it? Put the value of gamma D in the loosest condition and you will get the E maximum. So E maximum will become G, already they have provided 2.7 into gamma W, they asked us to take 10 kilonewton per meter cube, divided by gamma D is 14.21 minus 1. If you calculate, obviously how much you're getting, that is 0.9. This is the maximum void ratio you're getting. He's asking in the densest state, means he's asking what is the minimum void ratio. Just keep the values here. This is 0.6 already given here. Density index will be equal to E maximum. Just now we have calculated that 0.9 minus this E value already 0.6 we have calculated. Once again 0.9 minus E minimum. From here if you calculate the E minimum, you will get E minimum equals to 0.4. Just to do the calculation E minimum, you will get 0.4. That's all. These are the some important equation and derivation. If you'll just practice this, and practice more and more problem, you'll get command in the first chapter. That's all for the day. Do not miss the session on 9th. We'll deal with the consultation. Each and every point in the consultation I will be dealing on that day at 3 p.m. Do not forget. Thank you everyone. Have a nice day.